So here's our sundial designed for use at the North Pole. And if we were at the pole, we'd simply shove this into the snow parallel to the Earth's axis. And as the Earth rotates, it rotates counterclockwise. Every 15 degrees we get a new hour. There's noon, 1300 or 1 p.m. Now this dial works very well at the North Pole. There are issues though when you try to adapt it for use at other latitudes on Earth. We'll explore those issues in the next chapter. Let's use this globe to investigate the issues around sundial construction. We'll start at the North Pole. During the summer months, the Earth is tilted towards the sun, creating 24 hours of sunlight at the top of the world. The shadow cast by the extended axes at the North Pole moves across the landscape as the Earth rotates. Placing a dial over this post, we have a sundial. 24 equally spaced radiating lines representing 1-hour intervals. Every 15 degrees of rotation is equivalent to 1 hour. This sundial works perfectly, displaying time as the Earth rotates. Let's see how well this type of sundial works in other parts of the world. The equator is the line of latitude that circles the center of the Earth, halfway between the North and South poles. Let's place our sundial on the equator. The equator passes through Ecuador in South America. Our sundial is located on the equator at longitude 77 degrees west. I will rotate the dial so that 12 noon is pointed north. Notice how the shadow changes as the Earth rotates. Unlike the rotating shadow at the North Pole, the shadow here at the equator just changes length. In the morning it is long. As the day progresses, it gets shorter, disappearing at noon, then lengthening again throughout the afternoon. Not a very useful sundial. Let's try another location. I live in the Ottawa Valley in Canada at latitude 45 degrees, halfway between the equator and the North Pole. Our longitude here is 77 degrees west, the same longitude as our sundial in Ecuador. This means the local time here is the same as the local time in Ecuador. With the sun shining directly at the Ottawa Valley, I have set both our local sundial and the North Pole sundial to 12 noon. The sundial at the equator is unable to display time on this dial. Now that our two sundials are synchronized, let's check some other times. I will rotate the globe until our local sundial shows 10 a.m. Moving north, we see that our pole sundial does not agree. It displays the correct time as 10:30. The local sundial, here in the Ottawa Valley, is displaying the wrong time. Setting our local dial to 11 a.m. reveals a similar problem. The sundial at the North Pole indicates the correct time is 11:15. Setting our local sundial to 12 noon and moving north, we find that this time the sundial at the North Pole agrees. The reason the sundial works so well at the North Pole is because at the pole, the gnomon, the shadow casting post, is parallel to the Earth's axes. The gnomon at the equator is actually at 90 degrees to the Earth's axis, and the gnomon in the Ottawa Valley is actually at 45 degrees to the Earth's axis. Aligning the sundial so that each gnomon is parallel to the Earth's axis solves the problem. Our sundials are now repositioned with each gnomon parallel to the Earth's axes. From this perspective, we can see that all three sundials display the same time. This is true when they share the same longitude. The key to sundial construction is to design your sundial so that the gnomon is parallel to the Earth's axes. The next chapter explains how to design and construct a sundial for different latitudes. We know this sundial works well at the North Pole, and to make it work at other latitudes, we have to align the gnomon with the Earth's axes. Now I'll do that here. We're at latitude 45 degrees right now, and that means that I have to tilt the gnomon at an angle of 45 degrees and towards the north. So I'll point this north and estimate 45 degrees. There we are. Theoretically, we have a working sundial. I think you can see the problem. The sun isn't shining on our dial. There's no shadow to work with. The sun's actually shining on the back of our dial. There is a solution to this problem, another design of sundial. We'll take a look at that next. Here is a design of sundial that solves this problem. The gnomon is the edge of this angled card, and the dial lies flat. The sun shines on this surface. A sundial like this must be designed for specific latitudes. For instance, this gnomon is at an angle of 45 degrees, and the radiating lines are no longer 15 degrees apart. They have been drawn to accurately represent the time here at latitude 45 degrees. If you were designing a sundial for latitude 30 degrees, the gnomon would be at an angle of 30 degrees, and the radiating lines would have to be calculated for this latitude. Let's take a look at how to construct a sundial like this one. Any size of a sundial can be constructed. We will construct our sundial from Bristol board, starting with a rectangular piece 14 centimeters by 25 centimeters. Draw lines 1.5 centimeters in from each end. Draw one line 2 centimeters down from the top. Draw a line down the center of the card. Erase the corner construction lines. Next, draw lines radiating from the base at the angles shown. Use a protractor. These angles are correct for latitude 45 degrees north. Label the dial as shown. The gnomon has a base of 12 centimeters and is cut at an angle of 45 degrees. A simple way to make this gnomon is to cut a 12 centimeter square along its diagonal. Tape the gnomon along the center line as shown. A small bracket can be created to hold the gnomon vertically. Now that we've completed our sundial, let's set it up. The easiest way to do this is set it in a nice sunny location and rotate the dial until the shadow from the gnomon indicates the current time. Right now it is 2 p.m. So I'll rotate this dial until we see 2 p.m. indicated by the shadow, and then pin it there with a thumbtack. As the Earth turns, we can watch as the shadow progresses, moving towards 3 o'clock, 3 p.m. Moving on past 3 p.m. to 4 p.m., 5 p.m., and 6 p.m. The last number on our dial.